So this is project 5, where we're looking at the intermediate value theorem and the mean value theorem. So the mean value theorem says that if you have a continuous and differentiable function over the axis A to B, then there's a point C between these 2 points, that the instantaneous slope of some point C along the function will be equal to the mean slope of the function. So if you had a graph like this one, and your mean slope of the function over A to B here looks like that. The theorem says that somewhere along this function there will be a point C that is parallel to this slope. So that looks like it'll be about here or here. And these lines would be parallel and have the same slope.
So for our example, for the mean value theorem, me and Munzie used ourselves as the graph. So here's us being a cubic graph. And you can kind of see the outline of it here. We are the interval from A to B. And this line represents the average slope. And the mean value theorem says that there will be one or more point C's whose who will be parallel to the average slope. So if we make 2 points, and if we make 2 tangent lines, one tangent line there, and another tangent line there. And you can see that those 2 lines, tangent lines, are those 2 points, tangent lines, are parallel to the average slope.
So if the function that Keith and Munzie were demonstrating is f of x equals x cubed minus 2x, which looks something like this, and you're looking to find where exactly C is on these functions, you first have to find the overall mean slope from A to B, which would be f of, say this is 2, negative 2, f of 2 minus f of negative 2 over 2 minus negative 2, which comes out to be 2. So your slope over this way is 2. And then you have to find the derivative function, which is pretty easy to do. Just use the rules. So it would be 3x squared minus 2 from this equation. And then lastly, just plug in 2 to find out where these points C will be. So 2 equals 3x squared minus 2. And if you work that out, it comes to be x equals plus or minus 4 over 3. So that's going to be your 2 C points there and there.
Hi, this is Munzie. So the intermediate value theorem pretty much means that on an interval of a function from a to b, so from a to b, there is any c point between the two, so you can pick a c point anywhere. There's going to be a corresponding x value on that point, so in between the intervals there's going to be a corresponding x value. The intermediate value theorem was actually proven by Bolzano in 1817.
So to make an example, here's just kind of a random graph. So say this graph represents how many touchdowns you've had in a season. So you start off with 0, and at the end of the season you have 35. You had a real good season. And so on the second day, this is the second day here, you had 4 touchdowns. And on the 10th day of games, you had 30 touchdowns. So somewhere in between those 2 points on the graph, you had to have scored 15 touchdowns. That's pretty much what the intermediate value theorem states. And the reason we know that it's 15 and this works is because this graph is continuous. For the intermediate value theorem to work, you need a continuous graph because you need a value for like every y point on the graph. Because if you didn't, then I wouldn't know that a 15 has to be there. Because if it was discontinuous, say it was discontinuous at 10. That's 10. Say it was discontinuous right here. Well, then I don't know exactly what is because it's not a constant function. So